Let's look at how an IPv6 address is represented. So basically, the first thing you need to do in understanding this is remember IPv6 addresses are 128 bits long. To shorten those, they've written them in a string of hexadecimal values. So for every 4 bits, there is a single hex digit. So that gives you a total of 332 hex digits to make up the addresses. Now, IPv6 addresses are not case sensitive. They can be written uppercase, lowercase, doesn't really make any difference. So just to give you a rough idea, here is what the 16-bit segments or hextets is. So each one of those between the colons is 4 hex digits or 16 binary bits or binary digits, whichever you can confirm. So just so you can tell that each one of those, so if it was FFF, you'd see what? There'd be each one of those would represent 4 bits. They'd all be 1, 4 bits of 1, 4 bits of 1, 4 bits of 1, give you 16. So each in between these colons is 16 different 4 hex digits, 16 binary stuff. Now, there definitely is what they call a preferred format. And as you saw in that previous video or that slide there, the preferred format is writing IPv6 in an X colon, where each X represents 4 hex decimal values. The term octet in IPv4 dealt with 8 bits. With IPv6, a hextet is the unofficial term used for 16 bits. I don't like using it very much, but it's just a way of wrapping our head around that number. But it basically says for each X in this address here, each X represents 16 bits or 4 hex digits. So it basically means that preferred format means that you're writing an IPv6 using all 32 hex digits. Doesn't mean that there are some shortcuts and stuff, and we're going to, because this address, as you can tell, is pretty long, and there are a couple rules that we can kind of do to shorten this down. But a preferred format is using all 32 hex digits. But there are 2 rules that we can use to kind of reduce that number of digits. First rule is we can omit the leading zeros. So if there's any front end leading zeros in the address, we can get rid of them. So the first rule is omit leading zeros in any hextet. So just give you a rough idea, and remember it's leading zeros. So you got 01AB can be represented as 1AB. 09F0 can be represented 9F0. A0A00 can be represented as A00. Now 00AB can just be represented as AB. So remember, it is only leading 0. It's not trailing zeros. So you just got to be careful about that, because Cisco, they'll try to mess you up. So you could omit leading zeros in a hextet. And then the second one is omitting leading zeros. Now, make sure, oops, that's still rule 1. So that just gives you other examples. That was kind of confused me a second there. So that just gives you a rough idea of what can be done. As you can see, FE80, 00000 all down to 01. I can get rid of all those and leave it down to just a small subset. Now the second one is a rule of double colon. Now the second rule helps reduce the notation that it can replace a double colon. If you can replace any single contiguous string of one or more of the 16-bit hex text consisting of all zeros. So if you've got an address, so in here you got an address, 2001 colon DB8, so I got rid of the zero, leading zero, CAFE, then you got 1, so they got rid of the 0, so it was 0001, and then you had 4 zeros, 4 zeros, 4 zeros, and then 3 leading zeros and a 1. So all the leading zeros were removed. What you could do is now, instead of having all those zeros, you know, when you look at this, so you got what? 12, 4, 8, 12, and then 3 more there. So you got 15 zeros in this address that all can be emitted. So what you do is you put the double colon, and that got rid of, removed all of those hextets. So, but now remember, this double colon can only be used once in an address. So just keep that in mind. It can only be used once. So here's some examples. I'll let you go through them, but just know that I'm getting rid of consecutive zeros in the address. Now I can omit leading zeros and all zero segments with the colon, so just keep in mind you can do both. I'll let you go through some of those examples, and I'll let you go through that example, some of those. So I'll stop this video and we'll talk about address types in a second.